Hi everybody, my name is Anibal Azevedo and this is the class number 5 of the track number 4 on how we can apply artificial intelligence techniques on the container ship uh, or in the container port operations logistics. So now we're gonna start to create the crossover function, and to this we're gonna need the developments that we made in the class number 2. It appears like somewhere to the class number 2, but we'll talk about this briefly, and after this we're gonna start to create the crossover. So remember that in the description of this video you have all the code for free in the Google Club environment that's very easy to understand and to run things. So here we have the developments that explain it all in the class number 2, as I said, of this track. And what is this? Okay, so we need this uh, Anipop here is number 4. So we're gonna create the number of individuals. The number of individuals is 4, and okay, it's missing the bounds. Let's see the bounds. So here we have the number of unloading and loading rules. This is the total number of combination of rules, 12. This is the number of the size of the population for individuals, and each individual has these bounds, okay? Equal bounds, 1 to 1, 1 to 12. So the rules that can be created for these individuals will be a number from 1 to 12. Finally, here we define a list of lists. So what is this list of lists? It's just, okay, we need to define random int. We're gonna need this library from numpy dot random import random int. So here we are creating at handle a list of individuals, first individual, second individual, and each individual has elements that will be, this is the rule, the combination of rules that will be employed in the port 1, port 2, and port 3 for this individual. We have other individuals here. As you can see, the integers numbers will be arranged from 1, the minimum value, and the maximum value will be 12 at handle, okay? So now we can mix the information inside each individual. So this is properly the crossover. We defined a crossover point. For example, suppose that we selected this crossover point, and we selected this individual to have a crossover with this. So we selected this point. This one will be at the place of 10, and the 10 will be in the place of 1. So we created two new individuals by crossing these parts of the individuals and uh, uh, exchange these parts with the individuals. So this is the crossover um, function that we're gonna start to code now. So from, we're gonna need from numpy dot handle import hand. So from this library, we're gonna need this function hand, and I'm gonna start to code crossover. So this crossover function, we're gonna need the population, initial population that we created here. Also, we need this variable, and this variable is much the how can I say that? It's properly the individual that you selected for the crossover, okay? So we have a rate of crossover, cross. We can define this inside this method, okay, or outside. Or it can be just a parameter for the genetic algorithmic class, as you can see in the next class, okay? So what's important here, we're gonna use this population. This population is just a list of lists, as we can see here. And this population, we're gonna select one individual and the next individual here, right? So we have to be careful because this a variable should be not the last individual, since we're gonna need the next of the last individual is nothing. So let's take care about this point, okay? So we can also got a copy. So we need a copy of this list because we're gonna to don't change the original value. So if we do this, we are just performing a copy, which prevent us to copy the original individual that we got here. This is a reference to the individual. This is the value. We copy the value, not the reference here. So what's important? We need to made a random choice, and this random choice we should. Sorry for this. Okay, so we should make a random choice. We sort some value, okay, at handle, and see if this is less than the crossover rate. If it is, so we need to perform the crossover, okay? So we got the length of the individual minus 2. And if this is greater than 1, what this means is we cannot perform crossover in individuals less than, for example, imagine that the length of the individual is just 2. At least you have should have an individual with a length with 4. Okay, if you can do a random selected random a crossover point. So this is just the crossover point. So it can be 1 until this value that is computed that right here, okay? Else, there is no other choice. The crossover point will be at the point 1. So the individual it's too short. You cannot make a crossover point greater than the length of the individual. So to see this, let's see crossing point. Okay. So we're gonna see the crossing point, and also we can we should see we should do another thing, which is exchange the parts of the individual selected. So the first part of the individual of the second individual and the second part of the first individual will form a new individual C1, and the C2, the second individual, will be the contrary. So it's the first part of this individual. It will be a son. The first part of this individual it will be from the first individual, and the second part will be from the second part of the second individual. Finally, we should return both new individuals. So these are the new individuals that we can create by using crossover. All right. After doing this, we should now see the initial population, how it look like, and let's print this initial population. And after doing this, we apply the crossover function to this list of individuals, right? An important aspect is that we are calling that the second individual. See here, this is the index of the second individual. Will have a crossover with the third individual. So okay, so we can get also how this new population after crossover population. So after doing this, you can see the result. As you can see here, we selected this individual and this one, the second and the third individual in the population. And we said that the crossover point will be here, exactly here. So this 12 got here, and the number 1 got in the place of the 12 for forming these two new individuals. This is just to create new individuals from the previous ones. Imagine that we have high quality individuals. This is a little exchange of information between individuals that can provide new uh, high qualified individuals. That's it is the idea behind this crossover function, this crossover operator that we employ in genetic algorithm. So after doing this, we need also to create the mutation. The mutation is not that difficult, but it's almost the same idea. But the individuals will not exchange information between them. It's just to select one individual and select which parts of the individual will change at randomly. So this is also an important operator for genetic algorithms to create new solutions, to generate new possible solutions or new combinations of solutions. So I hope you find this video interesting and useful. Thank you for your attention and see you in the next video. Bye.